Thank you, Elena, and it's a pleasure for me to be on this podium again. I'm an epidemiologist despite being a medical doctor as a background, and when I started to work at the National Cancer Institute in Milan, the first things a clinician dealing with sarcoma that asked me was, please help us to show that rare cancers, when treated in expert centers, might have a better chance, to have an higher survival. I'm an epidemiologist, I'm used to work with data, and that's why since then I really try, to prove as much as possible evidence about the problems of rare cancers to make a change. And I think that what we heard so far, it's really a call to action to all of us, not only to, patient, to epidemiologists, but to all those that are seated that decided to join forces also in IDEA4RC. What I'll try to explain are the challenges that from the data point of view, we are basically facing. Because as we said, what we are really investing and leveraging on are networks, are existing networks of expert centers on rare cancers. We want to put data together to make them available to everyone. Andrea said to every stakeholders, we want researchers, clinicians, bioinformaticians, pharma company, and I said it again, pharma company, because anyone that can use data, to find drugs or to find any solution is welcome, at least from our point of view, to use the data that are precious. Of course, in order to do this, we have several challenges, and I have to admit that after the presentation that we just had, if you think only to what has been presented in Sweden, what we are facing in 11 centers across 9 member states is just, the point of an iceberg. Because if we could only go beyond, the one single centers we are working with, we will see how much, this heterogeneity can basically, increase, making our work even more challenges. So what we will try to address data heterogeneity, data findability, data security and trust, data access, and federated analysis, because, there was already a question around it. We present it as both a challenge and a solution, because it can be both, and we'll see immediately how. So this is what IDEA4RC has decided doing, so to address challenges. Why there is a problem of heterogeneity? Well, it has been said, if you have 6,000, different electronic health systems, in one region, can you imagine what we have in Europe? And Eurocan, by the way, that is the European Reference Network on Rare Adult Solid Cancers, include more than 100 different hospitals across 20 member states. Of course, here we are dealing with electronic health records. Andreas showed us a nice picture of, his desk. And you are a very tidy doctor, Andreas. But I can tell you that the system that Andreas shows is completely different in different hospitals. Most, of the EHR are in text. And we are dealing at European level with different languages. So we need to deal with different format, different language. And even when hospitals have tried to go from the hospital workers, collecting the data into a more type of standardization approach, with what are named the common data model, you will realize that different common data models do exist not only across the different hospitals, but also across the different diseases of the reason for which, you develop different common data model. The second challenge is the data findability and understanding. And here we will really stress both, the findability and the understanding. I'm sorry, but a lot of researchers and stakeholders still find difficulties in finding and knowing, the data are actually available. You don't have to reinvent any time, a new study, retrospective or prospective. The data exist. This is not, yet as widespread as it should be. But the point is that even for those that knows the data are available, it's really difficult to understand whether the data that are actually available out there are useful for what they have in mind. If I want to study, Elena mentioned head and neck cancers. If I want to study the second line of a nasal cavity tumors, well, that I need several clinical information that is not easy to find in what is named metadata, which is basically what currently is used to describe the data. There are very interesting information about how the data were processed, which population is covered, which type of data quality, might be there. But then as a researcher, I don't know whether I have information on stage, whether I have information on the drug, So these are not really useful. And of course, we need also to understand that if some data providers try to define maybe what we used to call in different way, data glossary, data dictionary. So you can see that even when hospitals try or any other type of data sources to provide a better idea about the granularity of the information that they manage, to make available, then they can be basically provide this information again in different languages, in different format, using different international standard classification. The other challenge is the data security and trust. Thank you. I keep on saying thank you to the two speakers that were before me, because they clearly introduced the problem. I have to admit that here maybe I can add that data security and trust is nowadays also a technological problem, because basically the threats, that are really behind the data are coming from everywhere. Not only from outside, but also from inside. And so the level of technicality that is needed to address, these different and increasing number of threats, it's so high that the expertise needed is not yet available across the different healthcare organization, hospitals, or whatever. And of course, GDPRs and other type of legal framework, on behalf of protecting data privacy are increasing the level of security, making, of course, this type of solution necessary, despite increasing the expertise needed to really implement and manage them. And unfortunately, I have to say that the GDPR, while it was supposed to increase the data sharing and the data use, because of the heterogeneity of its interpretation, has unfortunately increased the differences across countries and has also increased the responsibility of the data owners, that of course now is really concerned about where the data will go, how the data will be used, is responsible of the privacy of the patient or any other, or even of a healthy subject. So of course the point is that it's increasing the fear of losing the control. So the barriers for data sharing are increasing. So we are really wondering why we need a federated learning, type of solution, because data owners, unfortunately, are always more and more skeptical to share the data. And how can we handle any type of research? The other point, of course, is data access. We share a vision where we want data open to everybody. But the point is that we are far from there, because we are still a series of healthcare providers that basically still have different rules, have different procedures, have different, access format to deal with. And again, we are in Europe, so we have, different languages. And of course, all these different procedures are not interoperable, are not talking, to each other. And last but not least, why we think federated learning is a challenge nowadays. Because it's new. And when something is new, again, you don't always have the necessary expertise for handling it, for implementing it, for managing it, for really continuing and ensuring that this system will work and will be able, to work across the different system and structure. And I will really stop here because I think that the main topic of today are the solutions that we are trying to give, and I will leave the floor, of course, to those that will explain this better than I do.
Thank you, Annalisa. Any questions? Okay. So if there are no more questions, I leave the floor to the colleagues who have developed the solutions in IDEA4RC cancer project. So the first one is Eugenio Gaeta. He's a senior researcher at the University Polytechnic of Madrid. His expertise is in artificial intelligence, secure data, health informatics, distributed systems, and he will present how in IDEA4RC the privacy and security and data handling is managed through a new concept which is called Zero Trust. Thank you, Eugenio.
Hello, good afternoon, and now I would explain to you how we have made the federated approach on a common data model in IDEA4RC a reality. To do that, we had to prepare our centers through 4 different steps. In each step, we have added some functionality to build a system that finally allowed to the 11 center to perform federated analysis on a common data model. First phase of the journey for a center to be part of the federated infrastructure of IDEA4RC project is the data harmonization and availability. In this phase, we have basically collected the different sources at different hospitals, and we have analyzed it with the professional clinician and all the staff of the IDEA4RC project what should be the harmonized data model that is focused on oncology and in our case on the rare cancers. I would give you some insight on this part because after we do this work, we understand that we need a European common data model for oncology. So we started an initiative with HL7 to promote a diagnostic to standard data model for Europe. So I think that this is a good initiative to solve problem of heterogeneity of data. We need to be cohesive with each other and try to promote one single solution, not a solution every day, okay? And the other thing that we have done in this phase is to follow the wave of the artificial intelligence and use the new tool like large language model through structured and unstructured data. We have obtained already good result. The point is that at the moment we have only did the system with Polish because of problem related to privacy to share the data. And this is a common problem that I'm unhappy to say that GDPR has amplified, okay? After do that, we do not have forgot the standards because we have made that our common data model can be mapped on multiple standards. And we did this mapping on both OMOP and FHIR that are nowadays the most common used standard in healthcare. After do this, a center needs to go forward in the journey. And there is the second phase that is data quality and findability. During this phase, every center needs to evaluate and made available for understanding their data. Okay, so in this case, we have developed discoverability functionality aligned with what European Health Data Space is already doing, but we have added what is needed for a clinician and a researcher, the description of the clinical data, because European Health Data Space I'm unhappy to say, has described a data discovery functionality without describing the clinical data. That is useless for any researcher. We have also added some metadata like in HDS because we need the basis to use the data and so on. And we have also designed some redundancy on the data to make able directly clinician with no technical expertise to make query on those data. Okay, and this is what is referred to findability. So as IDEA4RC specific innovation, we have added some advanced quality control and on the data, and also support of agnostic quality check that can be configured by every center. Once the data are available, we have started to create the vault inside each center. And how we have do that? By using a novel approach towards the security that is called zero trust architecture. I will explain later a bit more in detail this. Okay. And basically in this moment, the data are secured and available in each center for local data processing. Okay, and this is what goes there. A part of this, during the building of the secure system, we have also implemented a governance framework that enable researchers to ask permission on the processing of the data for every center. Okay, this will be explained later by Ioanna. Okay, so by using this implementation of the governance, we are able to give access to the user, but maintaining always the data sovereignty in the local healthcare center. A final, but not less important, we have enabled the federated data processing by implementing inside each center the capability of process locally the data. So what will happen in this phase is basically when a user asks for a computation on the data, data are never aggregated and then the result is calculated. The request and the algorithm to process data is sent to the centers. The center provide the partial anonymized result on this data. These data are go back to a controller that is a central center that has no vision, no view of any sensible data, that finally aggregate to the result to give the insight and the output to the researcher. Okay, and a part of this we have also implemented, that this will be explained after the part on the data order journey, user-friendly interface for a researcher to perform data analysis without the need of a technical expert. This is because normally a researcher has to be able to perform the analysis that he wants to do on his own. He do not need any external support when he want to perform some research. And what you will see next are basically what is the data model and how the NLP extractor will work. What are the way that we inject data from sources inside our vault. And finally, I will give you more detail on how we grant security and privacy that is mandatory nowadays, and we need to deal with it. Okay? And I would leave the floor to next speaker. I don't know if you have any question. Okay.
Okay.
So thank you.
So thank you, Eugenio. I give the floor to Unai Zulaika. He is an associate researcher at the University of Deusto in Spain, and he's an expert in the data science, machine learning for healthcare. And he will introduce the data model which has been built specifically for our rare cancer research.
Okay, so thank you, Elena. Happy to be here. Hello, everybody. I'm Unai Zulaika, and I will introduce you the data modeling, interoperability, and natural language processing processes that we had in the IDEA4RC project. So first, I would like to talk a little bit about the data model. So as previous speakers presented this challenge about data heterogeneity, we have this problem where we have 11 different health organizations within the project, and we need them to speak the same language. We need them to have the same data model so we can share and trade data, right? So the question is, what is a data model? Well, you can think about a data model as a way to organize, to connect, and to store data. So the IDEA4RC data model has a few main characteristics which are important and I would like to remark. The first one is that it is simple and time-oriented. We are focused on the events, on the timeline of the patient. The second one is that it is comprehensible and focused on cancer data. This means that it is specific. The third one, it has clinician-friendly semantics. Okay, and the namings and the terminologies that we used for developing the data model are close to the clinical everyday routine, so then clinicians can easily interact with this data model. And finally, we designed the data model to be able to be used or easily be used for research queries and research questions, so it is fit for secondary use. Here you can see a depiction of a patient timeline following the IDEA4RC data model. I don't know if you can see it, but here there is this black line with a bunch of dates attached where you can identify different events in the timeline point of the patient. So a patient may have some information attached also here. We can have demographics information for the patient. We can also have previous treatments, previous diseases, and so on. And then what we are interested in is this cancer episode. That basically is some kind of umbrella entity where we can relate the patient to a cancer and then to all other entities and events that happen in the timeline. For instance, here you can see the point where the diagnosis happened. Then we have a set of treatments like surgery, radiotherapy, chemotherapy, etc. Also, we have treatment responses over there and disease phases. So the different phases where the disease may be, remission, recurrence, etc. So all entities are connected to each other, and this is the way we work to obtain and extract the data. So good, fantastic. Now that we have our data model, we can continue and we can start storing the data, right? We have the data model. Well, as Andreas presented and he showed, the problem is that much of the data is buried into the free text. It's buried into these EHRs. So we need to leverage natural language processing to solve this issue, right? The main challenge here also is that natural language processing is quite a new technology, but also it is really complex. We need to overcome a few challenges. So the first main challenge we found in the project is that we can't use the standard entity recognition approaches that were in the state of the art. We needed to go beyond. And for this, we needed also to link the entities that we found in the EHRs, in the text related to the patient, to the data model that I just showed to you. That's the first challenge. Second challenge is the nested concepts. So many times we can find difficult expressions in the EHRs, in the text. So think about this expression, for instance, partial response after second line. This is something that is really difficult for a model to understand and to process. Then we have the third challenge, which is the thinking. Many times in healthcare, we have difficult concepts that need to be that require deep clinical knowledge. So you can think, for instance, about the staging in a cancer. So this requires some knowledge about the cancers, right? And last, we have the temporal reasoning. as I said before, we show the timeline for the patient. So temporality is really important for cancer. And we want our model not only to extract the entities and to identify those that are most important, but also relate them or find the date where they happened to put them into an event timeline. So what do we offer? In IDEA4RC, we developed this set of natural language processing tools and models that have a few important characteristics. The first one is that it is an automatic approach. You can go from your EHRs, you just need to find the texts, upload them to an application, and then this goes automatically into a database. Second, it is oncology ready. We train the models with data coming from different centers. So it's oncology ready. Then it is time aware. We also tried the model to obtain the dates where the entities were recognized. Then it is ad hoc, secure, and it's deployable in your infrastructure. This means that if you have a server that has the requirements needed, you can have it in your health organization, and you don't need any cloud data or any cloud system. And last, it is multilingual. We only train by now with Polish, but we are including a few extra languages for the model. So here you have an example. So this is a patient text coming from an EHR. So the idea is that we would like to have our NLP model to extract the TNM standard or the TNM staging system for the cancer, right? So the first step is to identify the T. You can see the T is identified as 2, and for that, the NLP model goes to the text and identifies this highlight from here. So now we have the 2, fantastic. But still, we need to find the N and the M. So second, we go and look for the N. In this case, the model identifies the N as 0, and for this, it's not only looking at one part of the text, but it needs to check 2 parts. You see here and here. Last, it needs to look for the M, which is the data related to the metastasis, and then it goes to these 2 parts also to identify that the M is 0. Now, our model found everything we need for the staging system. So we have the staging to be T2, N0, M0, and we can relate this to our data model, and then we will see with the next presentation how this will go into the databases. So the point is that it works, okay? So we have been testing this with Polish data. These are preliminary results, but they are quite promising. So we can identify with a 65% of accuracy the patient-related information. This may include previous treatments, previous diseases, demographic data, and so on. Then we have a 90% of accuracy for finding the histological type of a cancer, which is really important for us. So we have really high accuracy there. And last, we also are finding a 60% accuracy for some treatment-related data, such as surgery and so on. So that's everything from my side. I leave the floor to the next speaker.
If there are no more questions, I have one question for you, Unai. Okay, so you presented that you have developed a data model. Okay, so the data model, of course, is based on the data that have been defined among the expert centers. But as you know, research continues. So maybe new data, let's say new knowledge may arise. And so how does your, let's say, technology allow to make use of this new knowledge and integrate it into your data model?
Yeah, really good question. Thank you for asking it. Yeah, so basically when we were designing the data model, we were focused on cancer. So from the very beginning, one of the most important things for us was, as Annalisa said, so we started with head and neck cancers and sarcomas, but we wanted our model to work with any kind of cancer. So the idea is that everything that we designed, the entities, the information that will go into the entities, how we connect things between each other, so it was designed to extend it to any cancer. So in the future, we would like to introduce new types of cancer, and we know that the data model is ready for this because we designed it having this into consideration. I don't know if there are any more questions. Okay, thank you.
Thank you, Unai. So next speaker is Vincenzo Falanga. Vincenzo will explain how, from the data provider point of view, so from the hospital who have the data in their, let's say, database, the data can be, let's say, transformed and made available through the IDEA4RC federated infrastructure. Thank you.
Thank you, Elena. I would like to introduce our solution for data gathering that was designed during the IDEA project. And I'm going to introduce you to our data gates paradigm, a kind of door through which your data can pass and can be managed to be arranged in the IDEA database in form of the IDEA data model. Well, we have learned that a health organization usually has its data stored in a plethora of formats and technologies. We can find structured and unstructured data, even data responding to one or more health data standards. So, using our paradigm, we wanted to make it easier to evaluate the data, to transform and organize them in a collection of tables useful for research purposes. Let me recap some useful information that has been shown till now, introducing it with a simple question. What are the pieces that compose the heterogeneity data puzzle? Well, we have data across 8 languages. The 80% of the data is unstructured and different data format and data quality. So it's a complex puzzle, and our answer to piecing this together is composed of a powerful and tailored extract, transform, and load process. In the end, there are a lot of pieces, but we can rule them all with one process that is in charge of recognizing and converting the information provided in a data format built during the IDEA4RC project and specific for the oncology domain. This is achieved thanks to the extract, transform, and load component, briefly the ETL, which was developed during the project. But what are the referring standards, and how was it possible to reach the goal? So we are going to inspect the solution in depth. We observe two main groups of data, unstructured and structured, and at the same time we choose to support two main health data standards, OMOP and HL7 FHIR, but other health standards could be added as well. These elements compose what we named the 4-gate data paradigm. This paradigm allows data to be collected and transformed, then arranged into the IDEA4RC database using the IDEA4RC data format. Now we are going to inspect each of these gates. The first one is the unstructured data gate. Obviously, this gate is used by those who have data formed as raw text. In this case, a process based on natural language processing techniques processes the data in order to organize them in a shape that is feasible for the ETL to be evaluated. The second one is the structured data gate. This gate is used by those who have data already structured and well organized in the database. In this case, the owner of the data is requested to fill a codes file. This comma-separated value file contains all the data that the system will evaluate, plus the quality of the information, a score that indicates the quality level of the information reported, the links among the information that are useful during the transformation process to preserve the data integrity, and the information time reference that is useful to evaluate data from the time point of view, even manage them as events if it is needed. Once the file is ready, it will be possible to send it to the ETL to start the data ingestion process. The third one is the FHIR data gate. In this case, the owner of the information is requested to send the data enveloped in a FHIR bundle. Once the bundle is received, it will be processed by the ETL that will convert the resources contained into the bundle in the IDEA4RC resources. The last is the OMOP data gate. In this case, the owner of the data is requested to execute a Python script to directly populate a database compliant to the IDEA4RC platform. This initialized database will be used to extract information using the IDEA4RC format. It is worth mentioning that the execution of the script could be made automatic. Summarizing, we can confirm that the usage of a consolidated standard like OMOP and FIRE, plus the introduction of a new way to collect the data, I'm referring to the codes file, enables the IDEA platform to speed up the data injection, granting at the same time both the data heterogeneity and availability, giving the user a strict control over the data quality. So, the next speaker. Thank you.
Now it's the turn to understand how we built the vault to grant privacy, security, and trust. Okay, you can imagine our environment inside each center of IDEA4RC as a secure processing environment, the same that the European Health Data Space Regulation mentioned in its text. Now, how it works in IDEA4RC? Traditionally, security, you can imagine the management of security at IT level like a castle, where we have only one entry door, and after you are inside the castle, all is free and all is available. We have changed this paradigm with the paradigm of never trust, always verify. In the similarity with the castle, what we have done is divide the castle in many castles. Each castle we have a castle for each resource that is independent from each other, and we are granting security from each one of these resources. Okay, this is what is called the zero trust. But this is for security. How we grant privacy? With privacy, we have adopted the federated learning approach. That is a privacy-preserving technology that is able to provide secure data analysis, because data is processed without exposure, and maintain the sovereignty of data on the centers, because data always stays within the local secure processing environment. Okay, and this is a high level of privacy. Okay, but what does it mean? This means that sensitive patient records never leave the hospital, and they are the model that come to the hospital to capture the information on the data and go back to the user for insight. So there is no private and no sensible data sharing in this process. But we need still one thing, because sorry, I would give you a very brief overview on how federated learning work. Okay, if I'm able to start the video. No way. No way to start the animation. Okay, what is the concept? Sorry? Could it possible to start the animation? Oops. Sorry for the okay, but to give you an insight how federated learning work, when we want to to calculate the average across the different centers, what we do is we calculate the local average and we just share the result of the local average. When the local averages are computed, then we make the data aggregation and we obtain the final result. In this way, data never leave the hospital, and the computation will give the same result of the case of the data aggregated in only one center. Okay. I'm not able. The only point that is missing is at this point is trust. What does it mean that we still mistrust? Because when we talk about a federated approach, the nowadays solution that you can have allow to the researcher or to the programmer to inject inside the capsule any kind of code. So following the zero trust model, I have to assume that a researcher could be malicious. So he could try to inject, for instance, a query on a single patient data and to extract, even in a federated approach, a sensible information that I want to maintain private. So in order to solve that, we have built the concept of trust in our platform that is basically related to the evaluation of what can be executed inside each capsule. We have developed an algorithm store where every algorithm that is in the algorithm store is assessed. And we grant that for every one of these algorithms, we can grant a high level of privacy. And when a researcher goes inside the IDEA4RC platform, he is only able to execute an algorithm but this is what I said before, an algorithm that is in our algorithm store. So in this way, we are sure that for that computation, there is no privacy issue related to the execution of the federated analysis. Okay, and this is more or less the way that we grant security, privacy, and trust in IDEA4RC platform. And I think that's all for my side. I would leave the floor to...
Okay. Are there any questions regarding this infrastructure? Oh, I don't have the micro. Where is the micro?
There is here a microphone. Okay.
Thank you.
So thank you very much. Very impressive work. So I'm Rickard Bramboll from RISE, Research Institutes of Sweden, and we also work with these federated learning approaches. And one issue that I'm sure that you're aware of, but that you didn't describe in your presentation, is the risk of the leakage from the final product. You're training a model by federated learning, you will get an AI system. And the European Data Protection Board, for example, but many other regulatory authorities have pointed to this problem that an AI system cannot be assumed to be anonymous, so that there is a risk for information leakage, including PII, from only a black box access to this AI system. Have you thought about that in your work?
In our platform, we mainly manage federated analytics than federated learning. What we have done basically is build the algorithm store. That means for each model that you want to run in the federated environment, you have to give us a data protection impact assessment, explain what are the threats that could be available. We submit this threat to each center, and if they evaluate the risk can be assumed, we publish the algorithm in the algorithm store. If not, this algorithm is not allowed to be computed.
Thank you. That's
This
a
is
very neat,
our approach.
very neat solution. Let's take the discussion to the break afterwards.
Of course.
I use this one. Okay, I have mine. Just to say that we have already developed a data protection impact assessment for several algorithms, because we are already using the Vantage 6, which is basically the support behind it. So happy to share the already developed DPI for, I think we're at 2 or 3 algorithms where we already developed. So happy to share them.
Okay, so the preview presented how we manage data from the data holder, so the hospital's perspective. Now we would like to show you how the user can benefit of the data that are presented, okay? And okay, the first speaker is Itziar Alonso. She is a researcher at University Polytechnic of Madrid, and along with her colleague, I don't remember the name, Adrián Dantas, sorry, Dantas, they will present how the user are, let's say, enabled to, let's say, understand which data are available and how the data can be, the data use can be granted to them.
So thank you. I will present, as mentioned, in the user journey. So the first phase of the user journey will be the data discovery. So this is a key phase for ensuring findability and data quality. So imagine us a group of users having a research question. They want to know if the data that we have available can answer this research question. So within IDEA4RC, they can look for the datasets that we have, the detailed information that we have about the variables and the quality information of these variables also, and compare all these datasets to find the best ones that better answer the research question. So this phase focuses on empowering the user to find the best datasets fast, easy, and with more confidence. So when the users have selected the best datasets for their needs, they go to the data access part, where through the data permit application, they can submit data access request. So this process is transparent, and the governance layers on the backend through with communication with the centers, they approve or they reject this request of access of the users. And of these granted access are compliant with institutional policies. So after these requests are managed by the governance layer, the users will receive notifications about the status of these applications. So once they have granted access of these datasets, they can start working with this data. So they will go to the next phase, which is the data use, where they can perform analysis and get insight of the data that they have access. So with federated learning in IDEA4RC, these users can get insights from the data without the need to extract this data from the centers. So they can select a set of cohorts that they want to perform the analysis on, and from the trusted algorithms that we have inside IDEA4RC, they can execute this algorithm and then visualize the result, the aggregated results of this analysis. So after this, it comes the final phase of the user journey, which is the project finalization. So in this phase, the user will extract the outcomes of the analysis. So IDEA4RC not only follows the user during the analysis, it also helps the users to report the outcomes. So in this phase, the users get insights from the data, summarize the finding, and report these outcomes, either for their analysis or for the wider community of research. So this phase is really important because it helps the user to publish the results to the wide community and help in advance of the knowledge. So this is the complete user journey of the IDEA4RC solutions, and this involves three main tools or layers. The metadata layer, which is related to the data findability and understanding, the governance layer that is related to the data permit, and the federated learning, which is related to the data use and data analysis. So all of these tools have integrated a virtual assistant that through AI helps the user to assist the user to use the tools. So now my colleagues are going to explain in more details these three tools or layers. So I will leave the floor to my colleague Adrián, who is going to explain in detail the metadata layer.
Okay. I'll be presenting the IDEA4RC approach to improve data findability and understanding. So one of the key aspects of working with data is to being able to find high quality and relevant datasets. As we mentioned during the challenges, we are focusing on three main pillars, such as unified codebook, comprehensive data description, and a unified search across repositories. So part of the comprehensive data description is involved detailed metadata, which refers to structural information that defines the variables, such as its name, its meaning, its description, format, or possible values that are really important to make easier to understand and to use this data for the researchers. So there are so many tools that are trying to solve this problem, but it's still difficult to understand what data is available and what not. And there are many cases of there are not enough granularity. So in IDEA4RC, we are trying to solve this gap, suggesting to apply metadata quality roles to ensure that this data is complete, consistent, and semantically interoperable, to be easier to use and ready for integration. We are also create a unified catalog that brings together data from different hospital centers to ensure that all these variables has the same structure and the same definition. So right now I'm going to show you a little demo of the Raven tool that we have developed. This will be the part of the metadata search phase. So this will be the landing screen where you can see overview of the project and the available datasets. There are two different options to continue, like with the login and without the login. For the demo, we'll go without the login, so it goes directly for the selection of the type of disease. There are head and neck cancer and sarcoma. Depends on what kind of analysis are you saying, are you doing. We'll go with the sarcoma. So continuing, we will go to the pre-selection variable screen, where you can see the different available variables with all the different information, the metadata detail, like the name, the description, the data type, the values. All these variables are grouped in different categories. For the easier way to search for them, you can also go to the search bar in case that you are searching for a specific variable. And you can also download the SCV file in case that you want to continue the analysis offline. After selecting the desired variables, you will continue to the next screen, which is the availability per center, where you can see more information about three key time points like diagnosis, progression, and recurrence. So depending what kind of analysis, you can choose the different variables. This will be the data quality screen, where you can see these critical data metrics like the number of cases, missing values, plausibility score, overall quality score, and so on. So this will give you more information of all these variables to take care when you are doing the analysis. To finish, you will create the workspace. Just type in the title and the description. After this, the user will be able to request the access of the data from the different centers through the data permit application. So thank you so much, and that's it.
Any questions? Okay. So as Adrián and Itziar have shown, data are available, but to use them, you need to get the permission from the data owners. So Ioanna from the Center of Research and Information in Hellas Earth. She's an expert in IT engineering and law aspects, and she will explain to you how we deal with the granting permission to use the data and to run the algorithms in each center adhering to the network of rare cancers.
So data access from the point where the researchers know which data they would like to use to the point where they can actually use it, following all the administrative procedures that are there to ensure compliance with the regulation, data protection, but also trying not to make this a barrier to actual research. This is what the European health data space basically aims for, and there are currently in Europe existing systems such as the Health Data Hub in France, findata, that are already in use and can serve as an example to the European health data space regulation implementation. But we noticed that although we can use their example, we cannot follow directly what they are doing because, for instance, they do not work with as a cross-border application. They need some information that is country-specific, or they have separate application stages that might complicate the process for our users in IDEA4RC. Also, there is no automatic linking with data catalogs, at least before login. And there is no interoperability in health data at EU, what has already been presented for the contract negotiation. And this is why we innovate in IDEA4RC. We have created an efficient toolset with configurable governance settings, because in IDEA4RC, in our governance model, we have the hospitals, the centers of excellence, deciding on what will happen with the applications, if they will be granted or not, instead of a national body. And we end up having data agreements by employing innovative technologies. We have a single application that can be revised multiple times if needed. We have created increased collaboration capabilities so that the multidisciplinary teams at the data holder institutions with data scientists, legal professionals, ethics specialists can collaborate on these applications in an efficient way. And we try to be as future-proof and as interoperable as possible by employing the data space protocol, which ensures interoperability for the applications and the permits, self-sovereign identity, and with this configurability, we can ensure that even if new regulations come up, we can easily adjust the system to align with them. This is a solution that, beyond the project, could be used for trusted health data holders who provide an opinion on applications and their interactions with health data access bodies. In a short demo that I hope will start automatically, we will see how the data holders can configure application templates so forms through which the research teams can apply. The data holders can specify different forms for each type of intended actors, medtech companies, pharmaceutical companies, research organizations, and can specify which members of their team will evaluate, will review each part of the information received as part of the application. They can also edit, in accordance with their institutional policies, what information exactly is requested from the applicants in terms of text, so some text to fill in, or files, such as the ethical approval. Once these are saved, they can also be later edited or deleted. And now, coming to the applicant part, even though there are many different forms across the centers, it is only one application that they need to fill in, because we combine all this information in a single form. They can select one or more team members to collaborate on the application and fill in information that is necessary in terms of the GDPR or the European Health Data Space Regulation, such as the purposes. Now, filling in all this information is not necessary just for the first time. They can create a draft that they will save and edit later. And then this application will be evaluated separately by each of the data holders, adding more comments and requesting changes, perhaps, or additional information to this. As an evaluator, as a reviewer, what we can see is that comments can be added, which will reach both the applicant and a study coordinator on the side of the hospital, who will collect all this information and see if the final decision should be to request additional information or to agree, reject, and accordingly. So in this case, it is all the comments that are received can be reviewed in order to decide upon the final feedback. If a cycle of revisions can start, or in case of an agreement, the center can select if they would like to have a handwritten signature and an electronic one. In case of rejection, it's necessary to add a reason for this rejection. Then, if we have an agreement, it is time to sign an automatically created agreement document so that we don't have to exchange emails for this procedure. And we take care to verify that the one that is allowed to sign the document is the legally representative of the organization. We use digital identity wallets for this. So this information is stored locally on the user's phone and can be verified by the platform, so that we can ensure they have a right to proceed with the application. This is based on the European Blockchain Services infrastructure and compliant wallets. And for the signature themselves, we use the digital signature services building block provided by the European Commission, so that we ensure that the signatures are valid, have legal validity. To offer some more details about the technologies leveraged, the wallets that we use, the identity wallets, are created by us at CERT. They are conformant with the specifications of the European Blockchain Services infrastructure, which is the first public sector blockchain infrastructure in Europe, and can work on cross-border applications. And in addition, we use the data space protocol, which is a detailed set of rules for data spaces, ensuring interoperability for the stage between the application submission and the permit granting, the issuing of the permit. Standardization for the data space protocol is also on the way. In summary, in our governance model, so with research teams applying for data access to 11 centers of excellence, 11 data holders that need to decide, we have created an efficient workflow, increased collaboration capabilities to work for those multidisciplinary teams. And our approach is tailored for federated learning in that this is the approach that we are promoting, and we need at least 2 data holders to agree with the research team in order to proceed. We ensure compliance with both institutional policies and the European Health Data Space terms, and also interoperability so that this system can work with in different data spaces and is future-proof. Some references, and the floor now for federated analysis.
Are there any questions? I have a question for you. Okay, Annalisa. No, you go and then I have mine.
Yeah, I mean, Eugenio described as the algorithm store as an additional layer, you know, to secure the control of what is allowed within the federated infrastructure. In your governance system, is there a way through which the different data holders can verify what has been done at the end of the full process? So what actually the user has been analyzing after the end of the analysis, basically.
Of course. This is actually a requirement from the European Health Data Space Regulation. And in our integration with the system, with the federated learning system, Vantage, we make sure to keep logs, identifiable logs, so we know exactly which user did what in the system, what they accessed, when they accessed it, in what they did with the data. And this is something that is accessible to the hospitals, to the data holders, so that they can keep track of the activities happening, they can keep a record of all the activities.
So my question, I have a couple of questions. The first one is, okay, you are saying that we are now experiencing this on 11 center of expertise, okay? So what if a new center want to be included? So how is this feasible within your, let's say, governance layer? And the second point is, okay, how is it difficult to grant, let's say, the authorization to sign for the individual, let's say, data holders?
For new centers to join, for new data holders to join, there needs to be a very short onboarding procedure. That is basically to register in the system and then to create the forms through which the researchers will apply, to insert all the information that is necessary for them. That is all that is needed from our part. What was the second question?
How is it difficult for the data holders to grant, let's say, to ensure that the people who sign are the entitled people? So how is it this, let's say, authorization level is provided to the signatory?
Okay. For this, we use the European Blockchain Services Infrastructure technology. This ensures that we know that there is specific format and specific content to this information. But for the end user, for the hospital, all they need to do is just make sure that their legal representative is registered in the system and that their IT department or administration office through the system accepts them as the legal representative. In the background, this would mean that this information is issued, let's say, as you issue an ID card from the National Police. In a similar approach, that means that the platform will issue a verifiable credential, as we call it, a sort of a document, electronic document with information that we know based on the blockchain, exactly what information it must include, who is allowed to issue such a document. And in turn, the platform, every time there is a need for a signature, verifies exactly if these rules are kept. So for the end user, it's simply a matter of accepting that the new registration of the user, but behind the scenes, there is a more complicated procedure ensuring the trust to all the organizations involved.
Thank you.
Thank you.
So, okay, so the next presentation will be by Frank Martin. Frank Martin cannot be here today, but he has posted a presentation and video presentation for us explaining how the federated analytics is performed within the IDEA4RC project.
Hello, good afternoon. I'm Frank, Research Software Engineer at Integraal Kankercentrum Nederland, or IKNL for short. Today I want to show you how we employed federated analytics in the IDEA4RC project and which challenges we solved in this domain. Using federated analytics can be challenging. The main challenge comes from the fact that it is an emerging technology, resulting in limited expertise and understanding on how the platform works and what is required to create a successful federated analytics networks by the participants. Each connected data center requires multiple disciplines to set up and maintain their data station. And of course, the bigger the network, the more parties are involved. This requires coordination. For example, when starting a project to decide on a common data model, or when a new analytics are required, or new data items need to be made available, etc., etc. And finally, the network requires investment, initially when creating it, and after that to maintain it. There are many big and small software federated learning and analytics initiatives. Some of these are more focused on federated technologies, and some of these are focused on a specific domain. All these platforms have their place, and each of them has its disadvantages and advantages. In IDEA4RC, we are using Vantage6. The ambition of this platform is to be the base layer for all kinds of privacy-enhancing technologies. It is flexible as it can be combined with existing algorithm libraries and different types of data sources. In the IDEA4RC project, we extended the Vantage6 solution. And today I want to highlight 3 of them. The first, data harmonization. We created a data adapter to connect the Vantage6 analytics to the Odyssey OMOP common data model. Secondly, federated data preprocessing. A set of tools has been created to allow researchers to transform or combine existing variables to new ones in order to use them in the federated analytics. And finally, a user-tailored experience. The Raven user interface enables the researcher to execute complex federated analytics without the knowledge of Vantage6. Let me give you a demonstration. But before I show you the process, let me first briefly introduce a research question. Retroperitoneal sarcomas, RPS, is a rare type of soft tissue sarcoma that develops in the back of the abdomen. Approximately 15 to 20% of all soft tissue sarcomas arise in this region, posing a unique diagnostic and treatment challenges. An interesting research question might be which factors significantly influence the prognosis of RPS patients. So in order to gain a little bit of insight on this question, I am first going to select the RPS cohorts, which has already been defined prior to this demo, and then we move on to the next step. We can see the included organizations over here, and we can explore the different variables that are available in the dataset. Let's have a look at the survival time. This is a numeric variable which contains the number of days that the patient has survived since the diagnosis. By selecting it, we can get an overview of that variable. It displays some descriptive statistics and some details per center. Let's also have a look at the FNCLCC grade variable. FNCLCC is the most common grading system for soft tissue tumors. This is a categorical variable, which in this instance has the grades 1, 2, and 3. We can see both the counts for the entire federated dataset and for the individual centers. There is also the option to create new variables by transforming or combining existing ones. But for now, let's continue to the analytics part. Here you see a list of previously executed analytics, and we are going to select an algorithm to create a new one. So there are many federated statistical methods available in the platform. For example, the Cox proportional hazard model, in which researchers are able to explore relations between survival time and one or more predictor variables. In this demo, we are going to use the Kaplan-Meier. Kaplan-Meier allows us to measure the fraction of patients living for a certain amount of time. We will stratify the cohort based on the FNCLCC grade to see if there is a difference in survival for these groups. And then let's execute the analytics. But before I show you the results, I want to briefly explain what is happening in the background. So first, the Raven UI sends a request to the Vantage6 server. All the included data stations listen to the Vantage6 server for instructions. For the Kaplan-Meier, the following instructions are executed. Each data station reports their unique event times, and to preserve the patient's privacy, it does so by adding Poisson noise to these event times. A central party combines the unique event times to a global list of unique event times. And in turn, these unique event times are shared again with all the data stations to compute the local Kaplan-Meier tables on these event times. And finally, these local Kaplan-Meier tables are combined to a global Kaplan-Meier table by a central party, after which they can be shared with the researcher through the Raven UI. Once all centers have contributed and the insights have been combined to a global Kaplan-Meier table, the researcher is able to view them. For the Kaplan-Meier, the curve is displayed and a log-rank p-value matrix is given. The log-rank informs the researcher whether the differences between the curves is also significant. In this case, as we also can see from the curves, the p-values indicate that the FNCLCC groups have different survival expectations. And then we have a final view, which gives the researcher insight in which data has been used for the computation. This is a similar view to what has been given prior to the computation, in where we could explore the different variables available. In conclusion, the IDEA4RC project is tackling complex medical research questions while ensuring data privacy. By utilizing the Vantage6 platform, we've leveraged the OMOP CDM for data harmonization, variable creation, and user-friendly interfaces that enable researchers. These advancements not only deepen our understanding of rare diseases like RPS, but also set the stage for future innovations in medical research. Thank you for your attention.
Okay, we don't have Frank here, but if there are any questions, I think that Eugenio can answer. Okay, so no more questions. Okay, so I think that Magnus Carlsson introduced a very, very relevant ethical questions for us, and an ethical commitment which we should fulfill. And he also challenged the GDPR and the legal aspects of data sharing, which sometimes constitute a barrier now for, let's say, improving the collaborative research across European countries. So we will have a next session dedicated to those aspects with an expert on legal and privacy preserving, let's say, strategies at European level I don't have the time, at 3:30, okay? So please, if you are interested in these aspects, come and participate to this roundtable where this aspect will be broadly discussed with Sebastian Ziegler from the Euro Privacy Certification, let's say, network. Thank you very much.